Today I will introduce to you Nicolas Ménégale. Not only does he speak many languages and is a gifted piano player, but also a Linux engineer, and that is the reason why he's our specialist today. So please give a hand to Nicolas.
So today I'm going to speak about the cloud computing and the Internet of Things. I've chosen in my title to demystify these concepts, because most of the time when you read Internet of Things like a newspaper, it seems really abstract. So the idea of this presentation is to make this abstract concept something practical. So I'm going to introduce myself and my company. So to be real quick on myself, so I'm working in the embedded Linux engineering field, and I'm also doing some trainings in this same field. And I am myself an adept of the open source software, so we will talk more about that later. And I also contribute to Buildroot, which is a special software to construct Linux system. About my company, so we are in France leaders in the embedded technologies around Linux and every open source technology. We are also developing Internet of Things systems, and we're also giving some conferences about the Internet of Things. And we will, at the end of the month, give a conference in Paris about the Internet of Things, and also in Lyon. So there will also be a workshop about the Internet of Things. So if you guys are going to be in France next week, don't hesitate to go there. We are 130 employees and one in Berlin, myself. And so I just put in some example of the people we are working with, Airbus, Peugeot, and someone else. So here is a plan of the presentation. So first of all, we are going to try to define what is the Internet of Things, and we are going to use some diagrams and simple words to explain this concept. And we are going to discuss then the advantages and disadvantages of this concept. And then the second part that comes is more technical, but don't worry, it won't be too technical. It will be only with simple words, and we will speak about producing and creating Internet of Things systems. And at the end of this presentation, I will show you some examples of connected objects, and we'll try to discuss on how this example works. So let's start with the first part, so giving a definition on the Internet of Things. So on this diagram, you can see the classical approach of Internet as it used to be since the beginning of Internet. So everybody as a human connect to a computer and then speak with humans or machines. This is classical. We've been doing that for 20 years now. And with the Internet of Things, this concept is changing. So the idea is now that machines discuss with machines directly. And so I put this little joke saying that they don't need me anymore, but
it's not a joke ever.
Yeah, but at the end, it's always human that produce and design the machines and program the machines. So, and the said end of that is like serving the humans. So we will speak about that later too. Actually, it's not a new technological concept because it only uses technologies that have been used for years. And it's the term Internet of Things is kind of a marketing buzz. It existed before with other names. And that's why I prefer to say connected objects or connected object system. So connected objects, the objects that is connected, and the connected object system is the whole thing with all the class things dealing with the objects. So we say that the Internet of Things will be the Web 3.0 revolution. Because it might change a lot of things in our lives. And as a reminder, the Web 2.0 was a social media revolution. So with all this Facebook and Twitter and stuff that appears. And that at the end, the social media revolution changes a lot of stuff in how we live and how we organize. So it might come later with this new revolution. So I'm giving you some figures to illustrate that it's really something growing. So I don't know the accuracy of these figures. It's given by IDATE and Gartner, but I mean, it's still big, even if it's not accurate. And they say that in 2020, we will reach between 30 billion and 80 billion of connected objects in the world, so more than human beings, actually. Anyway, we'll see if it will be true or not. The title of this presentation is Cloud Computing and the Internet of Things, but actually, I would say that cloud computing is included into the Internet of Things concept, because to deploy a connected object, you will need something to connect to, and the object is connecting to the cloud. So the cloud computing is only a part of the Internet of Things concept. And I would use as a less ambiguous word for cloud computing, remote service. It means that every service that a computer can give you, but you access it from, not from the computer directly, but from another part of the computer through the internet. So I made a little diagram to illustrate that. So I call that the classical Internet of Things workflow. So this is a theoretical diagram of how some connected object works, and then you can adapt that to the case you have. So CO means connected object. When I'm drawing these cubes, it means it's a connected object. So the example is a temperature sensor, which is connected to a connected object, which is an electronic device. And the word is internet. So this device communicates through internet to the cloud, and the cloud gives you a remote service, which is storing, processing, and analyzing the data. So the object connects and say, okay, my temperature now is 10 degrees, and so the cloud stores actually the temperature. And if the concept of cloud is not clear to you, you can think about a computer somewhere in the world that is running every day, every year, and you can always connect to this computer. We call that a server in computer sciences. So, and actually, as I told you before, there is always a human in the process, which has to get something valuable from this connected object. So this human is connected to the cloud to get the results of all the connected objects of the system. So basically temperature. So I have another example for you, which is a real-life example. So I chose this example because I saw news 2 weeks ago saying that a US company, that I don't really remember the name, is going to release a Bluetooth sensor for heartbeats. For people that have disease and need to monitor their heartbeats. And so this is this example. And the idea too is that a doctor can check in real time the heartbeats of his patients to see if there is a problem, to monitor, to survey. And so there is actually a simple electronic Bluetooth device that you have on your breast that communicates to your smartphone with Bluetooth. And then your smartphone goes into the internet and stores the information in the cloud. And this way, the doctor can come and see all the heartbeats statistics, and the patient can do the same. So that's what I mean by the diagram we saw before, like a theoretical diagram, and then for every connected devices, you can adapt the diagram to fit your needs, actually. So let's now discuss the interests of the Internet of Things. I mean, so the basic goal is to make human life better and easier. But we'll see after if sometimes it can make it harder, we'll see. But, and the purpose of the Internet of Things is to do that by collecting information on most of the things we can, and at every time. So to optimize the cities, to have a better Earth, like we saw on the diagram before, and like optimizing human energy consumption, For instance, with the new, in France we are going to have a new electricity counter in our houses that is connected and that can optimize the consumption of electricity. So, and there's a lot of idea about every aspect of everyday life that we can optimize. So these are just examples. About the risks. So, as in the social media revolution with Facebook and all this stuff, there are risks. Actually, the three ones are not new. I mean, with Facebook and the social media revolution, we had these kind of problems too. The privacy problem, the marketing problem of our data, and the monitoring problem. So we are kind of used to that, and we are still struggling with that. So, but for us, it's not new. What is really new, in my sense, with the Internet of Things, is all the hacking possibility we have. And there is already some example of problem with that. For example, like a month ago, I guess, some hackers found a way to take control of cars remotely because Progressive is an insurance company of the US, and they give you a dongle which you plug into your car, and this way they can monitor how you drive, and they can give you like a note on how good you drive or how dangerous you are. And so this dongle is sending data to the insurance company cloud, and then they can monitor and they adjust the price of your insurance, your car insurance. But actually, with this dongle, you could, like, from a range of 20 meters, you could take control of the car and deactivate the brakes on the car, which is kind of dangerous. So
this influences the price of your insurance too, I think.
Yeah, definitely. The other example I took is netcam IP. These are video cams you can put in your homes, and then you connect to your internet box, and then you can monitor what's happening in your house with a video from everywhere in the world. And most of them are not totally safe, and actually some of them are not safe, and you can watch a camera of people that don't know that you are watching them, just hacking the camera. And Shodan HQ is a research engine for connected objects. So, and it browses the web to find connected objects like cameras. So actually, you can go to this website and look for a camera in your area, and if you know how to, you can hack the camera and see what it is showing. Yeah, the second point is like more of a human point, is that, you know, as in the first diagram, we saw that, you know, the machine communicates between the machine. So sometimes we feel that we are losing control of it, you know. We are not part of the system. We are just, you know, conceiving, watching and designing it and using it, but we don't know what exactly they do. So, I mean, there is some scary stuff about that, but it always depends on how is it made, you know. There is always human programming these devices and stuff, but human can make mistakes too. So this is all these concerns that are interesting with IoT. So now we arrive at the second part, which is a little bit more technical, and we will discuss about how we can create and deploy things. So in a computer science point of view, this is a really wide system because it uses a lot of different aspects of the computer sciences. So, well, I put it electronic, which is not exactly on the computer sciences, but it's a field that you have to manage. Embedded systems, which embedded systems, I would explain that, is like the software that you put in the little electronic devices, like this one I'm going to talk to you later. And distributed algorithm is when different devices speak between each other and manage something, so they have to coordinate. Networking infrastructure is all the cloud-related problems, like you know that, for instance, Facebook have a big data centers with 20,000 computers running in every time. So this is not easy to deal with, and you cannot do that alone. Data mining, so what we call data mining actually is the fact of getting a sense from a lot of information. So let's say you gather a lot of information from connected objects around the world, and you have to get a sense from this data. So this is an algorithm stuff, and at the end it usually use some ergonomic and user interface design because people have to use it. So you have to do something which is easy to use and that people will use. So this is a diagram I showed you before, the classical IoT workflow, and I just put in some geek words for you to see that every part of the system is using different technologies. And what's interesting too is that most of these technologies you are seeing are not new too. So for instance, the IPv4, I don't know if it sounds you, but you are using it every day without knowing it. When you go to a web page, it's using actually IPv4 and HTTP. And it are, I mean, IPv4 was from 1981, so it's not new. And it did not really move since. But it will be replaced by IPv6 in some years. It's pretty complicated. And so this is the idea. So if you want to create a complete Internet of Things solution, you need a lot of different expertise in different fields of computer sciences. And so this is just to remind that the technology we use are not new. And the good thing is that as they are old, they are reliable, and we tested it for years and years, so it's easier to make something reliable. So the idea of creating a complete IoT solution is basically to combine all these elements that are already available and working, and to make them work together. So the idea seems pretty simple, but in the reality it's a little bit more complicated. So, as I told you, I'm really into open source software, and my point of view about that is that using open source software for developing your Internet of Things systems is really a good thing to do, because every brick of your system already exists. So, for example, Linux, this is the logo of Linux. So Linux is an operating system like Windows or macOS, which is free and open source. And it is reliable and scalable. It means that you can embed it into like a really small chip, and you can use it for big data centers too. So you can do a lot of different things with that. Also, open source software can reduce the fears of the users, because as is it open, we can see everything what is going inside. So we don't have to fear that they're going to sell our data to whatever they can sell it. And at the end, you support an ideology of sharing. So this is a personal thing, but I guess it's really important to me. And I think it can make things more open and more friendly to everyone. This is a quick example of something you could do at home if you had, if you want to connect something, whatever, your fridge, something, you can use this, which is a really small computer. You can make it pass. So this is a computer, but is as fast as a computer from 6 years ago, maybe. And the idea of that, this is a, how do you say plug in English?
Outlet.
Outlet?
No. Plug.
Stecker.
Stecker. And so you have the stecker, and you want to control it from your couch, because you're in front of the TV or whatever. So you can add a computer into the stecker, and you do some electronic stuff, and then you can choose which one you want to activate or not. So you can activate your lamp remotely, or your fridge remotely, or whatever you want remotely. So if you are a company that has an ID in the Internet of Things, you can do some prototyping with these little computers, and it can be really easy and fast to do. But quickly, an open source software, I think you've used some before with non-geeks. Like Android is part of Android are open source, but not every. Firefox, I'm sure you know it and you used it, they are all open source. It means that you can get the recipe of the program. But I mean, as a user, you don't really need the recipe. But I mean, I like this metaphor of the restaurant. If you go to the restaurant, they give you a meal and they give you the recipe at the same time. So when you get back home, you can cook again what they did. And if there is a secret ingredient into the recipe, they give you also the ingredient, so you can do the meal at home. So I told you about Linux before. It can really be used in the Internet of Things and the connected object stuff. And maybe you know also LibreOffice, which is like a Word equivalent. And Apache, you're using it every day, but you don't know. Every time you type an address of a website on your computer, the machine that gives you the web page is actually running Apache. Now, Apache is a software that gives you the web page, and we use it every day since a lot of years. So we have now the third part of our presentation. So I already told you about the Raspberry Pi. So the Raspberry Pi, the idea is that you can use it to connect whatever object you want to the internet. Like this lamp, if you want to connect this lamp to the internet, you could embed a Raspberry Pi into it and plug it, and then you could program the Raspberry Pi to control remotely this lamp. Another example that was done by a French company is connecting the streetlights of Clermont-Ferrand, which is a city in the center of France. And they connected the 17,000 streetlights. And as an employee of the city, you can check in real time which streetlight is broken and which is not. So it's pretty interesting, and you have a map with every streetlight and the state of the streetlights, and it controls the light flow to reduce the cost. I don't know exactly how it works, but it allows to save some electricity and to save some money for the city too. So it means that there is a little chip, like this one more or less, inside the streetlight, and they communicate between each other. And you can know at the end which one is working, which one is not working, how much does consume every streetlight, and you can do some statistics about that. I'm going to show you another open source software. The one before was not open source, but this one is open source. It allows you to have a monitoring screen in your house to control every devices that you have in your house, with some work and some electronic stuff in your devices. So this is a screenshot. So you have like a page for every room of your house, and then you can say, oh, I want to light that, poof, I want to light that, poof, I want to get down the stores and everything. You can also add some cameras if you want to monitor your house. And you can also create some scenarios, like you say, oh, if the sensor detects someone that's getting into the living room, then I will light this lamp at 75%. And you can define some behavior of your connected devices in your house. Thanks for your attention. This is the end of my presentation. And if you have some questions, I would be glad to answer it.